Hi, this is Tech with Costa, and today I'm going to share with you my developer setup for data and AI in 2024. I've used this setup to finish the Data Engineering Zoom Camp course by Data Talks Club, and I'm currently using the same setup for the Large Language Models Zoom Camp. And yeah, this is a basic setup to learn about data engineering, data analysis, data science, artificial intelligence, computer science, software engineering, a bunch of things, I guess. And yeah, I'm gonna follow this markdown file that I have stored on my GitHub account, and I will share the link in the description in case you want to follow along the same steps. And if you have improvement suggestions for this setup, please share down below in the comments. So you can read through this, but basically this setup was based on the data engineering Zoom camp that I did. And the course was awesome. Check it out. The community is very, very cool. And it's a great opportunity to build a network of people within tech and data engineering to improve your skills as a coder, programmer, engineer. Yeah, something like that. So I think this setup is also can also be extended for the LLM Zoom Camp, machine learning and machine learning operations Zoom Camp, and other programming projects or courses that you might be attending or working on. And yeah, a brief summary. So as the main operating system, I'm using Windows 11, but this is also applicable to Windows 10. Secondary operating system is Linux Ubuntu via Windows Subsystem for Linux, or WSL. The terminals are Bash and ZSH. Warp is very interesting also, but I'm not gonna cover it in this tutorial. Then IDE, I'm using Visual Studio Code, VS Code, installed on Windows. Version control, of course, Git and GitHub with automated SSH agent and passphrases. For Python environment manager, I'm using Miniconda to containerize and isolate the packages for each project I do. Containerization, I'm using Docker Desktop installed on Windows. For database, open source, I'm using PostgreSQL, and then I use pgCLI and pgadmin to connect to it. And infrastructure as code, it's Terraform, in case you want to interact with cloud components like Google Cloud Platform or Amazon AWS or even Microsoft Azure to create resources there. Then the first step is to set up Windows Subsystem for Linux, or WSL. I've already recorded a video on this. You can check it out. Install WSL. So then in terms of main operating system, I'm using Windows 11 again. You can do the same thing on Windows 10. Cool. Then we have hardware virtualization. It should be enabled. You can check this on Task Manager. Then you can go to performance, and here you see in my computer I have virtualization enabled. And this is enabled because I already did that in the BIOS of my computer. And if yours is not enabled, I suggest you to do that on the BIOS. So you basically search for your CPU options, and then you enable, depending on the brand of your CPU, either Intel VTX, for example, or AMD V. And I'm not sure if this is mandatory for the WSL to setup that I'm going to show you, but I always do this regardless because I always want to make sure that I'm able to create VirtualBox or VMware virtual machines. So, and it also might have some performance impact on your machine. So yeah, if you are able to do it, just enable it. Then turn Windows features on or off. Go to the start menu and search for turn Windows features on or off, then just go down, hold down, and then activate Windows Subsystem for Linux and Virtual Machine Platform. Click OK. Then save your work and restart the computer. Okay, so after restarting the machine, a Linux folder will appear on File Explorer. If you open File Explorer on Windows, you should see this new folder called Linux. It's empty at the moment because we didn't install any distributions for Linux yet. But yeah, then we need to install or update WSL. For that, we are going to open Command Prompt or CMD and run the following command, the WSL-update, several times until the latest version is installed. So for that, I can search for CMD or Command Prompt, open that. Then I can copy this code by using this. And then I can paste it using Control V or the right click in the mouse. And I can run this using Enter. And then I see that it's checking for updates, and I already have the recent version, the most recent version of WSL. But just run it a couple of times to make sure that you have the latest version installed. Then we need to check available Linux distributions. We can do that by running WSL list online, run that, and this is the list of distributions that you are able to install on your machine, and you can install multiple of them, and then I choose and install Linux distribution. So in my case, I want to install Ubuntu 22.04, so I just copy this. I can run CLS to clear this terminal, and then I just run this. Now just wait until this is installed. It should take a while. Okay, now you should see enter new Unix username. Just type whatever you want. I normally use my last name. This is the name that will appear in your prompt. I like it to be short and concise, so I just type Costa. And then new password. You need to insert a password to protect your system. And once you start typing it, you will not see it being typed because this is Linux. So just type it, hit enter, and then retype it. Make sure to type something you remember easily. And yeah, installation successful. So now you see the prompt already inside WSL. So if I cd into /, then ls, I can see the folders of the Linux system. If I go to the file explorer and then the Linux folder, I see Ubuntu 22.04 and I see the same folders here. So everything is working properly. And yeah, eventually, if in the future you want to uninstall a distribution, you can go to cmd. So let me close this one and open a new one. So you go to command prompt and you type wsl-list to make sure that you get the correct name to uninstall that distribution. Then imagine I want to uninstall this one. I copy this name and then I need to run wsl-unregister and then the name that I just copied from the terminal or CMD. But be careful, if you run this, it will erase everything inside your Linux distribution, so make sure that you back up your data if needed. Then after unregistering it, I go to add or remove programs, and I find the name of the Linux distribution and I just uninstall it. This is basically the file that it was used to install the distribution. Okay, then the next step is to install a terminal, and I'm going to use the native terminal from Windows 11. Normally this terminal already is installed on Windows 11, but I'm not sure if it is installed on Windows 10. I don't think so. If it's not, just go to Microsoft Store, the app from Windows, and search for terminal, and then find Windows Terminal. Make sure it's from Microsoft Corporation, and then just hit get. And then it will download it and install it. Click open, and then the terminal will appear. Close Microsoft Store, right click to pin this into the taskbar because you will use this often. So we can maximize this, and by default it's starting up as Windows PowerShell. And this is cool because in the same window of the terminal you are able to create multiple terminals actually. So I can have Windows PowerShell, then I can use command prompt, so this works in tabs. This is very useful. And of course I can also open the Ubuntu terminal that we just installed, associated with the Linux distribution that we installed. Cool. Then I want to make this terminal default, so I go to this arrow and I go to settings and I go to default profile, then I select Ubuntu and then save. Then I can close the terminal, close all, open a new terminal, and boom, now it's by default the Linux distribution. Nice. So then the next step is to update and upgrade the Linux distribution. Just copy these two commands and run them, sudo apt update and sudo apt upgrade, insert the password you defined, and then this is like, yeah, Microsoft updates, but for Linux, and then type Y to accept, enter, and it's downloading and installing the update. Okay, everything was installed, that's good. Now a quick tip about Windows File Explorer. So from Linux terminal, you are able to run this command to open Windows File Explorer in the current Linux directory. This is very useful to transfer files between your Windows machine and the Linux instance. So For example, if I go to cd // I'm on the root, then imagine I have a project inside the dev folder, right? From the dev folder, I can run explorer.exe and then space dot, and this will open my Windows File Explorer on that specific directory. And this is very useful to quickly find via UI the same folder, and then if I had to move files into this folder, I would just copy the files from Windows and paste them here, and so on, vice versa. Nice. Then you can review some Linux commands in this video that I've recorded. If you are a beginner or not, if you want to check it out, please do. It's basically basic Linux commands for beginners. I did a brief overview on that. Then the next step is to install or to set up Git and GitHub with SSH. So I already did some videos on that, but I will follow the exact same steps in this bigger video. So I have introduction to Git and GitHub, set up SSH for GitHub workflows, automate GitHub SSH passphrases, basics of Git and GitHub. And then you can also find some useful references here. And I will follow in this video these steps to make sure that we can create an SSH connection to GitHub in a secure way. So the first step is to install Git. Git should be installed by default on Ubuntu, but you can check that by opening a new terminal and closing the older one, and you can run Git. If you see a output like this, everything should be working properly. You can even run git space -- version, and it should output the version of Git. If it's not installed, you can do it by running sudo apt install git, then the password, and in my case it won't install, but you get the point. Then we need to generate an SSH key. So we use the same email as a GitHub account. By this point, you should have a GitHub account created. I'm gonna run this command. In your case, you have to replace this email by yours, of course, the same as your GitHub account. And I just copy this and I run it. Then proceed with empty file name, just press enter, add a passphrase that is easy to remember because you will have to type it often. And after running this command, a .ssh folder will be created, a hidden folder inside your user's home directory. And let's do that. So here, just type enter. Then we are going to create a passphrase. Type it, enter, type it again, and enter. So the key fingerprint is this, and the keys have been generated. So now we can check the contents of the .ssh folder by running this la.ssh, and you see two files. The first one is the private key. Never show the contents of it to anyone. And then the second one, .pub, that's the public key, the one we are gonna share with GitHub to connect to it. So by this point, again, you should have a GitHub account created. Then the next step is to add the public SSH key to the GitHub account. So let's check the contents of the public key generated in the last step. Make sure it's the file with the .pub extension, so we can run this command. If you follow the steps as I did, you should have the same file name. So id ed 25519. So this one, just run this and you see the contents of it. Left click, drag to select everything, right click to copy, or Control C. And then go to GitHub account, settings, SSH and GPG keys, new SSH key. So to do that, open your GitHub account, go to your icon here, settings, and then SSH and GPG keys, new SSH key, title, give it a name. I will type WSL, for example. Key type is authentication key. Paste the key here, the one you copied from the terminal, add SSH key. You should receive an email to inform you, but just ignore it. And the public SSH key has been added. Enter your GitHub password if prompted. In my case, it didn't because I'm already logged in, and so on. Then test SSH connection to GitHub. Run the following command. Copy this, go to the terminal and run this. Then you see that the terminal is trying to validate the authenticity of the host, github.com, and it's outputting this key fingerprint. So you will see a key fingerprint if this is the first time you are trying to connect to GitHub via SSH, and in this case it is because it's a new installed WSL setup. So before moving forward, copy this fingerprint starting in HA, etc. Ignore the dot, just copy the fingerprint, right click to copy, then go to this link. Then you can hit Ctrl F and paste it here to make sure that it matches properly and fully this one, the one that is associated with the algorithm that we just used to generate the SSH key, so the ED25519. Nice. It matches, so that means we can proceed, basically. So it matches, enter your passphrase. So now we can type yes, because it matched. And GitHub.com is now validated as secure, and it's been added to a known hosts file that the SSH folder manages, meaning that for now on you are able to connect with it without any problems. Now I need to enter my passphrase again, and we are gonna automate this in the future, okay? But for now, just enter it, and yeah, we've successfully authenticated to GitHub. Nice. You should have been successfully authenticated. Now we need to confirm the keys from the non-host file. So two files have been created inside the .ssh folder, the non-hosts and the .old one. Run the following command to check the contents of the non-host. So just copy this, run it, and you see 3 fingerprints, or yeah, things. So what I want to do is to open this link, which is actually the same, but never mind. And now you need to verify if the ones that appear on the terminal match these 3. So here we have 3, starting with github.com, 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 and you want to make sure that everything after github.com matches the ones from the terminal. So let me copy the first one, the SSH ED25519, copy this one, and it matches perfectly the first one. Then the second one, SSH RSA, just copy it and then paste it here with Ctrl F, and yeah, it matches also. Then the last one, ECDSA, go here and match this, boom, it's done. Now that means we can proceed. If everything matches perfectly, move forward. Let's remove the old non-host file. For that, you run this. So before that, let's actually go to cd.ssh la, and you see the files here. Now I'm gonna remove the non-hosts.old one and la again, and I see that is being removed. So everything looks good. Now I want to configure Git with my identity and you with yours. So run the following command to specify who is going to sign your commit with a username and an email. And I use my first and surnames and the same email address as the one I use in my GitHub account. So run these 2 commands, but replace the contents with yours, right? So here I'm specifying the username as Diogo Costa and my email is this one. So I just run this. After running this, a .gitconfig file has been created, and yeah, if I LA here, I can see the file here, .gitconfig. So if I cat it, I can see my identity inside of it to validate it. So everything is fine. Then I can create a folder for projects on the user's home directory. This folder will contain all your projects. Name it Git, projects, code, or whatever. I normally call mine Git. So I can run make dir and then Git. So if I run ls now, I can see an empty folder called Git. I will store all my projects inside this folder. Then I can clone the original course repo. From this point forward, the process applies to pretty much any coding project you might be following or creating yourself, if you have to clone a repository from GitHub, of course. I will exemplify this using the large language model ZoomCamp course by Data Talks Club, because it's starting now, and yeah, it might be useful for some people. And I can run something similar to the following commands to clone the original course repository into the Git folder. If your folder has a different name than Git, replace it here and get the SSH address, so this one, from the target GitHub repo. So what I mean by that is, for example, if I want to search for LLM ZoomCamp, I can go to the GitHub page and I can go to code, SSH, and copy this URL or address. And then, yeah, it matches this one. I'm gonna clone this repository to my local machine, Linux machine. So I copy this and I paste it here. It's cloning the repository. I need to enter the passphrase again. And then inside Git, I see the LLM ZoomCamp. if I go into it, I can see the files and folders that I find in the repository, right? So now I have a copy of the same repository in my machine. Okay, so I do this to have easy local access to the course materials, to follow the materials and copy eventually stuff that I need to progress in the course. Then I just run the following each time I start working to ensure my local branch is up to date. So I go into the project file, which I'm already there at the moment, and then I run git fetch and git pull to make sure that the repository is up to date. Of course, if I run it now, it will be most likely up to date because we just cloned it, so it's unlikely to have changes in the meantime. But yeah, it's asking multiple times for the passphrase each time I interact with Git, but again, we are gonna automate that in a bit. Okay, so then create and clone your own course repository. This is the repository you are going to use to store your code from the course, to be able to share it with others, to showcase it as a portfolio, to submit homeworks and stuff like that, and to document your journey, I would say. So go to your GitHub account, go to repositories and create a new repository. So go here, right? Your repositories, and then new, and then just give it a name. I'm going to call it this one. So LLM Zoomcamp-2024. Then description, I will call it this. You can call it anything you want. Public, to make it accessible by everyone. Then add a README file and create repository. Okay, and you have a new repository to work with. Clone the repository by running something similar to the following. Replace this stuff with yours, right? You know the drill. So if I go here, SSH, copy this. I already have the link here, so I can copy this and paste it here and enter the passphrase to clone it. Then if I go to git LLM 2024, yeah, I can see that it contains the README file that I just cloned. Okay, so then I also have some videos about Git and GitHub workflow examples. Check it out. I have part 1 and part 2. Then the next step is to set up Linux terminals. I use Bash and ZSH, and I have 2 videos about this already. One is about how to add GitHub branches names to the prompt in Bash, and the other one is about improving ZSH with the package or framework OmyZSH. So first of all, let's back up the .bashrc file, which is the configuration file for Bash, just in case we mess something up. So just copy this, paste it here, LA, and now we see 2 files for bashrc. This one is just a copy, the back one, to make sure that we have redundancy. Let's customize bash prompt for Git to show the branch there. So let's customize the bash prompt to include the Git branch name on it each time we are inside a .git folder. So run the following command to edit the file, nano bashrc, .bashrc actually. So copy this file, this command actually, and then the editor will open. Then use the down arrow or page down key to find the following rows. You need to find these 5 rows or lines. Just go a bit down and find these ones. They are on top of unset caller prompt, force caller prompt. Then put the cursor on top of the first one, then hit Control K multiple times, 5 times, to delete all those lines. Then leave this one there, and then add the following rows to replace them. Copy this, and here just paste it with Control V. And now we can Control X, Y, enter to save the file. So here, the PS1 variable defines what happens in the terminal prompt, using ANSI codes for callers, etc. So we use the function parse git branch and a regular expression here to get the activated branch whenever we are inside a .git folder automatically. Then we use concatenation here with the result of this function to include the branch name into the prompt. And we can also define the caller that will appear. In this case will be red. You can change this here if you want. But this is super useful for Git and GitHub workflows because if you are using Bash, of course, because then you can always see the branch you are working with there. I mostly use ZSH, which has a lot of customization frameworks with themes, colors, extra functionalities, such as OhmyZSH, which I will be showcasing in a bit, OhmyPosh, Power Level 10K, Starship, and so on. But yeah, if you want to use Bash, I included this to show you how to do it. Then let's refresh Bash. Open a new Bash window for the changes to take effect. Open a new one, remove the old one. And now to validate this, let's go to a Git repository, such as the one we've cloned in a bit earlier, LLM Zoomcamp. Just go there, and now, boom, you can see the main branch here in red. You can check that. Of course, that's the activated branch here, and the same with status. You see that we are on main branch. If you would create a new branch, it would automatically change this to the correct one. And okay, so verify that the selected branch appears in the prompt automatically. It did, so we are safe to delete the .bash rc backup, because apparently everything is working. Delete it or not, it's up to you. I will delete it, so I just run this, and now I see only one bash rc. Cool, then I can install ZSH. Type Y, enter. Then we have ZSH. And now I want to install OhmyZSH to improve the standard ZSH terminal. Type Y to make it default shell, and enter your password. Now we have OhmyZSH installed. Okay, now I want to automate SSH agent passphrases for both Bash and ZSH. Append the following code to the bottom of both Bash RC and ZSH RC files. This way you only have to enter your passphrase once per terminal per computer startup. The thing I was telling you that we would automate. So now just copy this code, then nano.bashrc, go down, up to the end, until the end, and then just append in the bottom this code, like this. Then Control X, Y, enter. Then do the same for .zshrc. Go down, enter, paste, Control X, Y, enter. And it's done. Then let's open multiple Bash and ZSH windows to validate this. Let's test the SSH connection to GitHub on both to make sure it's automated. So copy this, open a new terminal, and when you open a new terminal, it will by default ask you one time for the passphrase. I will enter it. And now I can test the SSH GitHub connection. And it worked. If I run it again, it worked. If I open a new terminal, if I open Bash instead of ZSH, I can run the same thing, and it's working. So it's automated now. Now let me close the terminal, close all. Okay, next thing I want to do is to set up VS Code with WSL, the IDE we are going to use to code inside of it, actually. So find the original official Visual Studio webpage, find the download Visual Studio Code, and download the Windows installation setup, because we want to install this on Windows, not on Linux, okay? Then open the downloads folder, execute the setup. I accept the agreement, next, then tick everything except the create a desktop icon. I don't need it. Next, install. Actually, I hate icons on the desktop. That's why I have everything empty, just to avoid distractions. So then I launch the Visual Studio Code, finish. Okay, just wait a little bit. And you should see a message in the bottom right corner about WSL, because it should detect automatically that you have WSL installed. That's why we install VS Code after installing or setting up WSL. Let's maximize this. Let's pin Visual Studio Code to the taskbar, because we are going to use that often. Then you can follow the welcome steps if you want to learn more about it. You can follow the steps of the welcome page. You can also read the documentation here to learn more about VS Code functionalities. For example, WSL interactions, Git and GitHub setup, Python, Docker, etc. But essentially in this image, you can see that we have Visual Studio Code installed on Windows, and then it connects remotely to Windows subsystem for Linux, or the Linux instance, through a WSL extension that I will show you, right? So the next step is to install WSL extension. It should pop up automatically, and it did. If not, go to Extensions panel and find it, WSL by Microsoft. So what you do here is basically you click Install if it prompts, and then it should install automatically the extension here, and a welcome page will open. You can follow it if you want. I will close this one and also this one. Okay, so as I was saying, if this message didn't pop up, you just go here, Extensions, and then you search for WSL. And then you open WSL and make sure it's the one from Microsoft and install it. And that's it. Now we just close Visual Studio Code. Cool. Then let's go to a project folder on the Linux terminal and execute the following code from that folder. So open the terminal, and I want to open the original LLM ZoomCamp folder using GitHub. Using GitHub, no, of course, using code, sorry, Visual Studio Code. So I copy this and I can execute it, right? And it's installing automatically VS Code Server for Linux. This is the thing that is responsible to create automatically the remote connection between your Windows machine and your Linux machine within WSL through VS Code. Then, yes, I trust the authors. Close the welcome thing. And yeah, so you can also go to, of course, Git and LLM ZoomCamp, and then you could execute code space dot from here, and the same thing would open. Okay, this is the normal workflow for you to open a specific project folder from within Linux terminal. So a remote connection to Linux distribution is created automatically by VS Code Server. We will work on VS Code installed on Windows with automatic remote connections to Ubuntu through WSL2, leveraging both operating systems, meaning I don't have to dual boot. I have Windows and Linux in a seamless way integrated in the same machine. For my needs, it suits the purpose now. So yeah, trust the authors if prompted. I already did that. Then we need to check. We don't need, but I want to show you the WSL tab. And on the bottom left corner, find the WSL tab, left click to see several options. Since we have launched WSL directly from the folder on Ubuntu with the code command, the remote connection is established automatically. We do not need to do anything else here. We can close everything. So if I go here, I see the options I just mentioned. You can check them out, but this is basically if I wanted to connect to a different distribution. If I had other WSL installations or distros, I could do that from here. But at the moment, we are already connected to Ubuntu 22.04, and you can see that here in the bottom. So it's fine. So then it's time to explore VS Code. This is optional for you, but I want to show you regardless. So let's check the Explorer panel. This is the Explorer panel, right? You can close it and open it. And this basically contains all files and folders that exist within the directory you are currently working at, meaning what you see here is the same thing as you see here, right? Then we can open a file. Let's open the readme.md file, and one click opens a temporary tab, 2 clicks open a fixed tab. Let me show you. If I left click before that, let's zoom in and zoom out because I think this is kind of small. So quick tip, if you hit Ctrl+, it will zoom in and increase everything. And if you Ctrl- in the keyboard, it will do the opposite, zoom out. So let me just put it like this. So now let's open the README file. You can click once, left click. It will show a new tab with italic font. This means this is a temporary tab. If I open another file, so for example, Project MD, it will replace this one because it was temporary. If I double left click it, you see, so if I click it once, if I double click it, it will go from italic to normal font. And this means it's a fixed tab. So if I open project now, it will open as a new one. Same thing. Yeah, you get the point, right? So yeah, then this is a markdown file, right? It's the code that will be rendered to show something fancier. So I can preview it within VS Code. So I can Ctrl+Shift+P and search for markdown, open preview to the side. By the way, Ctrl+Shift+P enables you to search for commands within VS Code. It's very useful. So then I can search for markdown something, and yeah, I find open preview to the side. If I click it, I will see the rendered result on the right, and the scroll will be more or less synchronized. And you don't need to do this. You can actually use a shortcut. If you hit Control K, you will see this message here. Control K was pressed, waiting for a second key, of course. So after this, you need to type V. So Control K and then V, and it will open this automatically. Control K, V. This is very useful. I use this every day. So yeah, now you see the markdown on the side, markdown result. Then check search panel. Enables you to search through all folders and files, even with regular expressions. It's very useful. If you go here, you can search for stuff. For example, yeah, Git. If I want to find files that mention Git, for example, it finds everything I need. So on the README file, on a documents.json, so you get the point. You can search a lot of things within the repository, files and folders. Then you also have the run and debug panel. I'm not gonna show you this now, but it's very useful functionality within VS Code to debug any type of code in an interactive way. It's very worth to study and to understand. And yeah, it's basically this thing here. Then you can check extensions panel. I already showed you that to install WSL and so on. But now I want to install code spell checker by Street Side Software. So go to extensions, paste it here, and yeah, install the first one, I guess. So it's called code spell checker. You have other languages too, but I just want the standard one by Street Side Software. Install it, and this basically helps you identifying spelling mistakes in English and correct them for you. So for example, if I type extension, this is the proper way of writing, right? So then if I type extension with an S, it's an error, it's underlined. So if I right click, spelling suggestions, it shows me options to correct this. Extensions or extension, whatever. So you get the point. Nice. Then I can also install To-Do 3 by Grunt Fugly. Cool name. But go to extensions, just search for To-Do 3. It's this one by Grunt Fugly. Install it. I install it. You do whatever you want, right? But then this is cool because it enables you to, whenever you type to do with caps lock, right? Imagine this is to do number 1, right? And then imagine I have one here, to do number 2, and imagine I have another to do in another file on Project MD, for example. This is to do number 3. Now, if I open this thing here, this panel, I will see that in this repository, I have 2 files mentioned, and then it groups the to-dos here. And then I can click them to go through everything I need to do. If you are coding Python, SQL, or whatever, you can leave these comments, these to-dos inside comments. It's very useful. Okay, let me just ignore these changes, and then yeah, there's a ton of extensions to explore for pretty much everything you can imagine. So then we have the Remote Explorer panel. It shows you the WSL targets that you are connecting to, and you can be connected to different ones. At the moment, we are connected to this repository within Ubuntu 22.04. Okay. Then let's open a new terminal. You can do that by going to Terminal, New Terminal. Make sure you remember this keyboard shortcut because I use it very often. So if I click here, it will create a new terminal, right? And this is a terminal that is directly integrated with our Linux distribution, similarly to this one that I've just been interacting with up to this point. And at the moment, you see that by default is initializing as ESH1 because that's the default terminal on the Linux distribution. About keyboard shortcuts and terminals. In my Portuguese keyboard, I use Control Shift and then cedilha, which is a version of C, to create new terminals, and I use Control cedilha to close and open the current terminal. So if I hit Control cedilha, I can close, open. If I hit Control Shift cedilha, I can create a bunch of new terminals, which is very, very useful. And all shortcuts that you see are customizable within VS Code. Just go to File, Preferences, Keyboard Shortcuts, and then just customize whatever you want. By default, ZSH opens. You can open multiple different terminals actually. So for example, you have ZSH here, right? You can open Bash. You can open a multiplexer, for example, Tmux. Tmux is basically fancy stuff within terminal that enables you to create splitted multiple windows inside the same terminal. You can split the terminal. So if I have a bash here, right, I can split the terminal using a ZSH. Now I have ZSH on the right side and bash on the left side. So you can do pretty nice stuff here. Okay. This provides direct interaction with the WSL distribution directly from within VS Code. Okay, then check Git plus GitHub tab. On the bottom left corner, we have direct access to branches options. We can create and switch between branches, and the repository updates automatically in the Explorer panel. So here I see that I'm here on the left side bottom. I see that I'm on branch main. If I click it, I can create new branches. I can check out to other branches and so on. If I would have new branches here, if I switch between branches, automatically this Explorer would automatically update accordingly to the branch I'm working at or working on. And then I can also find or interact with Git via the UI, meaning if I hit Ctrl-Shift-P, I can search for Git, Ctrl-Shift-P, and then search for Git, and I can see a bunch of options with direct integration to interact with Git. So imagine I want to Git fetch or Git pull. I could do that from here, right? So with VS Code, you can either use UI commands to interact with Git or use the terminal to do whatever you want, right? For example, if I run git fetch, right, I can do it from here. And you see it's updating the source control, right? Then it asks me, would you like to Visual Code to periodically run git fetch? I don't want that because I like to fetch the code myself, but you can do it. And so you can run git fetch from here, right? And it will do the same thing. Run git pull, right, to pull the code after fetching the code, right? So git fetch and then git pull, and I can do the same thing here. So git fetch, right, and then git pull. I can also run or synchronize the changes from this icon here, the circle thing. This action will pull and push commits from end to origin main. So I can do that, and then I should have everything properly synchronized. All right, just explore these things. I think it's useful if you are a beginner to understand these concepts. So then we can check the source control panel. And to follow this, let's switch to our course repository. So let me copy this. Let me close this instance of VS Code and run this to open our course repository that we just cloned a while ago. And now, since the current work folder is also a Git repository, the source control panel will show file changes and enable you to add, commit, and push changes directly to the remote repository. This means that it even shows differences for edited files line by line. So the source control is this thing here. It's very fast to add changes and commit them here with messages instead of using the terminal, but you do whatever you like more. And now I can edit the README file, and I open it here. Imagine I add hello world. So before saving the file, you will see that there's a white dot here, or circle. This means that I've changed the file, but I didn't save it yet. You even see green lines here, meaning that comparing to the original file, these are new lines added. Then if I save the file using Ctrl S, you see that the white dot, it's now a capital M, meaning that this file is modified. And in our local repository, this file at the moment is different than the file that is stored on the remote repository on GitHub, right? And there's a lot of these minor details on VS Code, but it's really helpful for you once you know them. And I don't know everything for sure, but it really boosts your productivity and you start learning these things, and it's very cool in my opinion. So then if I open source control, you see a 1 here, meaning that I have one change now, right? So I see that readme.md file is changed. If I open this, if I click here in this change, I will see directly a comparison between the older version of the file and the new one. So I see green lines here, meaning that these ones are new lines, okay? I can, for example, delete this part, save the file, and now if I check the changes, I understand that these 3 lines are new, and I've deleted this part specifically, the by Datatox Club part, right? So you can see these differences with colors and so on. Green shows a new added line, red would be removed, etc. Then I can undo this part. I just want to add hello world. I save the file. Then I can stage the changes from here, so I can add this. Now this is staged similarly to git add on the terminal. Let me just open a new terminal, okay? Then I need to write a commit message, and I can commit and sync changes to push the changes to the remote repository by typing OK. So here, let me add added hello world. Then I can commit, I can click here. I can also commit and push directly and so on. But I can commit by clicking here, or I can simply hit Control Enter, and then I can sync changes, and then this action will pull and push and so on. It's the same as this circle. So I hit OK, and now it's syncing the changes with the remote repository, meaning that I should see the same changes here. 1 second. So LLMs Zoomcamp 2024, and yeah, I see hello worlds here and the commit that I've just added, and yeah, I've added 2 lines. The repository is up to date now, right? Because we just pushed the changes. In the terminal, in ZSH, you see that if you type enter, you see that this is the current prompt, right? Okay, if I remove hello world now, and if I save the file, if I hit enter to update the prompt, you will see a cross here. This means that I have uncommitted changes, meaning my local repository is not equal comparing to my remote repository. This is a visual, interesting way of seeing that I'm missing commits to make sure that everything is synchronized. Of course, if I undo the change, if I save the file again, if I refresh it, it will disappear the cross. So these are minor tweaks that you can also do in the terminal. This is the default behavior of OhmyZSH. You can customize your own, you can use other themes. Yeah, a lot of stuff. By the way, terminal customization is a big rabbit hole. Be careful. Once you start doing it, it's kind of addictive, and just be careful. And yeah, and that's it, man. That's it about VS Code. I think this kind of covers the basics of it to interact with the thing. Just another thing. So imagine I want to. Okay, first of all, I don't want hello world there. I just want to remove it. Okay, real case scenario. I don't want hello world there, right? I delete it. I save the file. I go to source control. I hit removed hello world file. I commit, enter, sync, boom, and it's done, right? So the change, this is very fast, and probably there's even faster ways of doing it, but I just edited this in a very fast way. Once you get used to these workflows, and I'm still learning also, but whatever, it's boom. In the beginning, Git and GitHub, it's kind of this scary monster that no one likes to learn, I guess, and it's kind of hard in the beginning for a coder. But then it's daily thing. It's like natural, it's automatic, right? Anyway, so let's move into the next chapter. Let's set up VS Code for Python on WSL with Miniconda. I do this because, again, I want to make sure that if I'm using Python for multiple projects in my computer, I want to make sure that the packages I install for one project, they are isolated from other projects. Meaning, imagine I want to use pandas in 2 different projects. On project 1, I'm using pandas version 1. On project 2, I'm using pandas version 2. I want to make sure that I don't install version 2 on project 1 and vice versa, right? So this is the best practice of installing and interacting with Python. Don't make the mistake of starting projects and just installing the same packages for everyone in the same stuff, in the same environment, default environment, either on Windows or Mac or Linux. Just don't do it. Install Miniconda or Anaconda or VENV software and then create different environments for different projects. That's it. I think this is the best way. If you have other suggestions, let me know. So let's install the latest version of Miniconda. Run the following commands to install Miniconda. So this will create a new folder, Miniconda 3, and it will get the latest version of Miniconda from the server, and it will install everything, and it will refresh both bash and ZSH to be able to incorporate conda commands. Now we need to reopen the current shell. After reopening the terminal, we see that now behind the prompt, we see a base thing. This means that the base environment from conda or Miniconda has been activated. And we can also check conda commands. They are installed now, so we can interact with environments from Miniconda. Miniconda files will be stored on Miniconda 3 folder containing the envs we create in the future. Default environment activation. As you saw, base appears now behind the prompt, indicating that the base conda environment is activated. And I do not like this. So to prevent conda from activating the base environment by default, I need to run the following. Run this, refresh the terminal, and now it's not activating any conda environment anymore. Okay, now let's interact a little bit with conda environments. Create a new conda environment for the project that we have. The project folder is named LLM ZoomCamp 2024, right? But the environment I will create is the project folder name plus, in the end, -env to differentiate between the project name and the environment name. So, and in the same command, I want to install a specific Python version automatically. So we can create the environment by typing conda create and then -n, and -n is just a simplified version of --name. So if this would be --name instead of -name, it would be the same thing. Then we specify the name of the environment we want, in this case LLM ZoomCamp 2024-env, and then the Python version. In this case, I want to install inside this conda environment Python version 3.10. So again, I like to use the project folder name plus -env in the end. Copy this, change the project name and or Python version if you need, paste it here, run it. It's creating the environment, type Y, enter. So these are the packages that it will install in the Python environment. So when you create a conda environment, it will actually create a separated Python engine that is associated with specific packages. And in this case, it's initializing that environment with these basic Python tools, right? Packages. So then it tells us to activate environments, you can type conda activate and then the name of the environment. You can also deactivate them using conda deactivate. So let's activate it by running this, conda activate, etc. And now you see that it's activated here behind the prompt. Then list envs. If one is activated, it will show an asterisk on it. So run conda env list. Sorry, copy this again. Sometimes it doesn't copy, I don't know why. But conda env list, right? And now you see two different environments. The base one, that's the original standard one. I don't really use it. And then LLM ZoomCamp 2024 env, the one we just created. And since it's activated, you see that it contains an asterisk here, similarly to Git branch, right? And then you can deactivate the current environment by typing conda deactivate, and the name will disappear again. Deactivate. The name will disappear behind the prompt. That's it. We can also delete conda environments by typing conda remove -n, then the name of the environment -all. Then I will just exemplify deleting one. So type Y again, enter. So it's deleted. If I run conda env list, it disappeared, right? Then we can create the same env by avoiding typing the environment name from the target project folder. Meaning, instead of writing the name hard-coded here, I can run this and this will grab automatically the last part of the path where we are currently working at. So this means that if I go to git LLM zoomcamp 2024, and this would work for any name folder name, right? If I run this, echo, etc., it will output automatically the name I want. So it grabs automatically this name, LLM zoomcamp 2024, and concatenates afterwards -env, because pwd is home, Costa, git, LLM zoomcamp, etc. It grabs only the last part by using base name and then concatenates this, and boom, I have the name I want. So if I run this is just an automation detail, right? Type Y, and you see it created the same environment name with Python 3.10. If you omit Python 3.10, a new environment will be created without Python installed, and if you want Python there, you would need to install it manually afterwards, after activating it. So if I replace, just to exemplify, right? If I replace the current environment, same environment, without specifying a Python version, it already exists, so I will remove it and I will reinstall it, right? If I activate it now, right, I can run Python. No, I can't, because I didn't install a specific Python engine or version inside this environment that I have currently activated. So I need to install Python manually if I want Python inside this environment. So I type conda install Python 3.10 to specify a specific version, then Y, then I can run Python, and now it works. So I have Python now, so I can print hello world, and it works. I can exit with parentheses, and it's working. Let's close this. Let's open VS Code from project folder by running this. Okay, let's run this. Okay. And now I want to test the integration that I've just created with VS Code plus Python/miniconda, right? And for that, I want to create a Python file. I can do that in two ways. I can go here, add a new file. I could also create a new folder and so on, but I could write script.py for Python extension, and then I would hit enter and the file would be created. I will hit escape to quit this. I can also, from this folder, I can also run code script.py to create the file automatically. And then I save the file with Ctrl S, and it already tells me that I should install a Python extension, and I do want to do that, so install. If this doesn't prompt, just go again to extensions, search for Python, and install Python by Microsoft. Install the extension, that's it. Associate the correct Python interpreter on VS Code. Click the Python interpreter tab on the bottom right corner, or Ctrl-Shift-P and select Python select interpreter. Choose the environment you've just created. Refresh the terminals inside VS Code. Okay, so what I want to do now is to close this extension thing. I have a script.py, right? And now, since this is a Python file, VS Code already identifies that this needs to be run by Python, right? And since we installed the extension, I can see Python here, so this is the language I'm using. And I can see the interpreter associated with VS Code now. If I click here, I can specify a specific interpreter or Python installation that I want to use. And of course, for this specific project, in this specific repository or folder, I want to use the environment I created. So I want to select the LLM zoomcamp 2024 env. I select this one. And now it tells me I need to, a warning, I need to refresh the terminal. So I close the terminal, Control cedilha to reopen the terminal. And since I specified the interpreter here, conda, now the environment is already activated by default on the terminals I create within VS Code. If I open bash, the same thing happens. Okay, this is good. So from now on, whenever you open the project on VS Code, this conda environment will be activated in the terminal and the interpreter correctly selected. You can select the interpreter here, okay? But you can also hit Ctrl-Shift-P and search for interpreter and then Python, select interpreter, and it's just the same thing. So whenever we install packages via the terminal, ensuring the correct environment is activated, the packages will be isolated into it, avoiding corruption of other projects. So if I want to install a specific package for this project, I need to make sure in the terminal that I have this environment activated. And then I can run, for example, pip install pandas, enter, and then it would install pandas inside this environment, okay? Without messing other projects up. Okay, cool. Then we need to restart VS Code and validate the activated environment and selected interpreter. You might need to do this a couple of times to save the setup. So now just close the VS Code instance, run this again, and even after restarting the computer, if you do this, it should appear the right interpreter here and the correct terminal conda environment activated here. So do this a couple of times and it should do it properly. Just make sure if you open the project, you have the correct interpreter selected here, if you are working with Python, of course. Then, Python Manager workflow. For each project inside the Git folder that require Python, I create a specific conda environment to ensure package isolation. Then I associate each VS Code instance to each project /conda environment /interpreter. Now I want to show you some Python interaction options you have. The first one is script, the most basic one, I guess. So let's add this code to the script.py file, paste it here, save the file. So this is a comment because it starts with an hashtag in Python. This is a print statement. It will print in the terminal whatever you type here inside single quotes. In this case, I want to print hello world string. This is another comment. This is a variable named x. This is a variable named y. This is an integer 2 that we are assigning or saving into the variable x. This is an integer 5 that we are saving inside a variable named y. This is a print statement that basically prints the result of the multiplication between x and y. In this case, it should give us what? 10. Yeah. Then, to execute the whole script, we can use the UI play symbol on the top right corner. This will use the current activated conda environment interpreter, and I can click here, run Python file. Automatically a new terminal named Python will be created, and it will execute Python and then the script name using the conda environment we've created, right? Miniconda3, envs, our conda environment, and then it executes. And we see the outputs of our code here. Let me just hide this. And we see hello world, the output from this, and the output from this is 10. Okay. Of course, we can also run the same Python file by typing Python and then script.py, and we see the same output because we have this environment activated. And of course, we can also do it from here. So if I go to the Git folder, I can ls, I can see the script file here. If I have the environment activated, I can run Python script.py and I see the same thing, outputs. If I conda deactivate this environment, if I run Python script again, it will not work because by default, Ubuntu doesn't recognize Python directly, but it recognizes Python 3. So this is the same thing. But we want to make sure that we have the right environment activated, okay? Then the second type of Python interaction is Jupyter cells. Sometimes I want to run sections of my code independently, similarly to how you might work in a Jupyter notebook. This is useful for debugging purposes during development. It's more flexible in my opinion. So let's duplicate the script.py file. Open the Explorer panel, left click script.py, hit Control, you will see a plus sign there. And now you can drag it and then release the left click to copy or duplicate the file. Right click, rename, call it cells.py. Okay, close the script one, close the readme one, and now we have cells.py. Okay, now install the Jupyter extension by Microsoft. Go to extensions, search for Jupyter. Make sure it's Jupyter from Microsoft, install it. It will not only install this one, it will also install a bunch of others, and that's good. Close this. Just to make sure, let's close VS Code and let's reopen it in the same folder, okay? Just to update the extensions. And then we can separate code in cells or sections by using these tags. Hashtag and then 2% signs. So imagine if I do hashtag percentage here, it will create automatically one cell below it. If I do the same thing here, it will separate this part into a new cell. So now I have two cells that I can execute independently without having to execute the whole script, which is very useful. So to execute one cell, use the UI, meaning I can click here, for example, run cell. After clicking on run cell, the interactive window will appear on the right, and this window will show you the outputs of the cells that you run on the left side. And you need to install a kernel, IPY kernel. Install it, and this will be installed inside the activated brand conda environment. So this one, which is the correct one, so install it. It's installing the IPY kernel, and this will be used to compile the cells you execute on the left side. You don't need to use these things here to execute the cells. You can also use keyboard shortcuts to do this. But in the meantime, you see, it already shows me the output of the first cell, hello world. Imagine I want to execute the first cell again. I can select it here and then Control Enter, and it will run it again, but the cursor will remain in that cell. If I type instead Shift Enter, it will run the same cell, but the cursor will go to the next cell. Again, if I select the first one, Shift Enter, it will run both cells independently whenever I want and show the outputs on the right side. Yeah, we can check the outputs from each cell in the interactive window straight away. We can check the Jupyter tab with variables from current session. We can change the variables and see them updating. This is basically, you see more actions here. If you click variables, it will open this Jupyter thing here. You can see the variables here directly, meaning I have two variables now in this session, X and Y. Both are type of integer because they are storing values, number 2 and number 5, X and Y respectively, because of this. If I change Y equal to 10, if I run this again, now the result is 20 and Y changed to 10. I can create a new variable called name, for example, and I will call it Diogo_Costa. I will run this. And now I see a new variable called name. And sorry, this is a string, size 11 because it contains 11 characters. And the value it's storing, it's a text Diogo_Costa. Okay, we can use clear all to empty or to clear the outputs. We can restart the kernel here. This is useful to clear all the variables here and sometimes to fix some bugs that might occur within VS Code. You can change the kernel here, right? Yeah, but I want to make sure that it's the same as the conda environment I have currently. So now I want to run everything again. So Shift Enter. I forgot to mention, but you can also use this interactive bar here. And yeah, for example, you can interact with the current session that you are working with. For example, if I type X and then I can execute the code here, I can see the output of this variable, which is 2 at this point. I can also type Y, for example, and I can execute the code using Control Enter. And I use this all the time. I can also insert other commands. And yeah, this is a flexible way for you to either execute cells that you code on the left side, but dynamically you can also interact live with the current session here. And whenever you type anything, it also gives you some suggestions. So for example, I can type name.split. And for example, if I want to split this variable, Diogo_Costa, by the underscore, I could, for example, run this. And now I have a list containing Diogo and Costa separated. And then I can press up arrow to go to the previous command. And for example, I can select only Diogo by typing square brackets with a 0 to access the first entry of this list. Or I could also type -1 to access the last one, which is Costa. Cool. And then I want to click here, save. Okay. And this will save a new file named cells.ipynb. This is a notebook, Python notebook. And I can, for example, move these around, right? I can swap the windows and do these cool things. Then I can close the cells.py. I can close the interactive window, and I see this in a format of Jupyter Notebook. I can clear all outputs. I can run them all. To run them all, I need to specify a Python environment. Again, let's select the one we created with Conda. And now it uses it to create the outputs again, to compile the code. Let's save the file. And yeah, so we can interact with it in a similar way as a conventional Jupyter Notebook on browser. Then, Jupyter Notebook on browser with server. If you really want to run a Jupyter Notebook on browser with a server, do the following. With the proper Conda environment activated, install Jupyter package. So let's copy this. Let's go to terminal. I have the proper Conda environment activated. So I want to install Jupyter package inside this Conda environment. Just wait. And now we have Jupyter installed. Okay. Then I want to initialize the Jupyter server by typing Jupyter Notebook on the terminal. So Jupyter Notebook. And now this terminal is dedicated to handling this Jupyter server. And automatically a port is being forwarded, the port number 8888, so we can access this Jupyter server on the browser. If we click open in browser, okay, we can check Jupyter server. We can also run localhost 8888, and you see the same thing, okay? So next step, we need a token. To do that, we need to create a new terminal, and we need to execute Jupyter server list to check the servers, Jupyter servers we are running. Then we copy the token here after the equal sign. We paste the token here. We define a password, log in and set new password. Now we can double click the Jupyter Notebook. And boom, we have the same thing on the browser. We can, for example, clear outputs of all cells, and we can run each one again. We can also print name if we want, and it's Diogo_Costa. If we Control S to save the file, or if we click here to save it, then we can close this and this. We can go back to the VS Code instance, and the same file now is updated within VS Code because it's the same file we just edited, okay? And that's it. Now it's time to download and install Docker Desktop on Windows. And before that, let's run the following command and confirm that Docker is not accessible yet on the terminal. So Let's create a new terminal and just run Docker. And as you can see, it didn't find anything. So we need to download Docker for Windows. So go to docker.com and find the download for Windows link, download the setup, execute the installer, click yes. I don't need a shortcut to desktop, click OK. This takes a while. Okay, so installation succeeded, close. If your Windows version is not home, mine is, imagine instead of home is, for example, enterprise or other, you might see an additional tick box during setup. If so, do use WSL2 instead of Hyper-V, because if you use WSL2, it has more performance comparing to Hyper-V. Since I have Windows Home, that didn't show up during the installation. After this, run Docker Desktop after installation. So just search for it, Docker Desktop, and run it. You should see something like this: Docker Subscription Service Agreement, accept, skip survey, starting the Docker engine. In my case, I'm already logged in because this is not the first time I've installed Docker in this computer, but if Docker at this point asks you to sign up or to sign in, I recommend that you create an account on Docker and sign in. In this case, you see that I'm already signed in with Tech with Costa. So create an account and sign in. Then check for updates on the bottom right corner. There's a new version available for me. I click here, download update, update and restart. Click yes. And then it will refresh Docker and install the new update. Okay, the update just finished. Open Docker Desktop and you should see engine running on green color and the latest version has been installed. Dismiss all, and that's it. Then ping Docker to taskbar. At this point, save your stuff and restart your Windows machine. So after restarting the machine, run Docker Desktop again. Okay, maximize it. And you can always check if Docker is running or not in the Windows system tray icon in the bottom right corner, so here. And you see Docker Desktop running, right click it, you can quit, restart, pause, and yeah, you see that I'm logged in here and Docker Desktop is running. Then the thing that you have to ensure to make sure that Docker is properly connected and set up with WSL is the following. Open Docker, go to settings, then go to general, and you need to make sure that this thing is ticked on. So you need to make sure that use the WSL2 based engine is on. Windows Home can only run the WSL2 backend. WSL2 provides better performance than the Hyper-V backend, the thing I've mentioned in the beginning. So this needs to be activated. Additionally, go to resources, WSL integration. This needs to be enabled. Enable integration with my default WSL distro, and then enable integration with additional distros. Enable this, apply and restart, and then click cancel. That's it. It should work now. Run Docker on the Linux terminal. Let me enter my passphrase. Run Docker, and you should see an output like this. You can even run docker -- version to see the current version. So Docker is running now within WSL, but installed on Windows. Now let's run your first test container. Copy this, Docker run hello world. Docker will fetch the image from the remote server. Then we'll spin up a container, and from the container, it will output this message, hello from Docker. So this is a good sign. Okay, if you run this command, and if you get an error similar to this one, saying incorrect username or password, you need to do the following. Go to the terminal, replace this command with your email, and copy this and just run docker logout and then docker login username and then your email associated with your account on Docker. Then insert the password from Docker account. This is just to refresh the login, right? And then login succeeded. And then you rerun docker run hello world and it should work. So to summarize, the image should be fetched from the server and the container will run, showing the test message output hello from Docker. Open Docker desktop and see the container with a random name and its image. Meaning, if you open this, you will see a container with a random name associated with the image hello world. So the image is here and it's named hello world. This is why Docker is able to spin up a container, a virtual container, with the image that it's downloaded, basically. So run another test container, copy this, go to the terminal, open a new one, and just run this. This is a new one, so it will fetch another image. And now it's basically port forwarding something to 8080. So just go to localhost 8080 to see the output. And you see, congratulations, you ran your first container. This is also working. So then you can also run docker run Ubuntu to fetch a Ubuntu image, for example. And this is a container containing Ubuntu, literally. You see the prompt here. You can ls and you see the folders there. You can exit. And finally, spin a container for Python 3.10. These are just examples of containers you can fetch. You can do a bunch of things with Docker to containerize your applications and services that you need to use within your projects, data projects, apps, whatever. And it's really an industry standard nowadays. So literally, this is a container containing Python. So yeah, we can print cool, and it works. Exit, parentheses, and that's it. Now, stop all containers and delete all containers and images via UI. You could do this via terminal also, but let's do it here. So go to containers, select all, stop everything, delete forever, images, select everything, delete forever. There's no volumes, neither nor builds. So that's good. Then it's time to set up Docker with PostgreSQL database. So let's define the containers on Docker. So for that, let me go to Git, and then my course repo. Then I can run code from here. I can close this file, and I need to create a new file named dockercompose.yaml. The new file is here. I save the file. Then I copy this code here, I paste it here, I save the file again. And basically here we are defining two different Docker containers. The first one is PG database, and this is an image of PostgreSQL database. Then we define some environment variables for connections and so on. And then the second container is pgadmin, and these containers will be in the same network, so they will be able to connect with each other, meaning we are going to use the container containing the pgadmin image to be able to query and see what's inside the database on the first container, the Postgres one. Then we are also creating volumes, and we create a volume for pgadmin data because we want to make sure that whenever we stop the container and we refresh your computer, for example, the servers that you created there connecting to the first container, for example, the definitions will stay there. So you need a place to store that information. That's why we create a volume. And we also create a volume for the PG database one to make sure that the data we store within this database is stored locally in our machine. And whenever we spin up the container, the data will be there also. So we map a folder within our machine to a folder within the container. And these are synchronized. You can read this through to understand this a bit better. But then let's make sure that all containers are stopped to free up all ports. And yeah, we just did that, so we don't have any containers. Then what we want to do is to go to the same folder where we saved the Docker Compose YAML file, and we just want to run Docker Compose up to spin up these containers. So we are in the right path. Just run docker compose up, and now Docker is pulling both images that we need to spin up these containers. Okay, so it's downloading. Okay, cool. So after pulling both images, after running docker compose up, the containers should run. The terminal will be dedicated to these containers. So you see here, if we go a bit up, you see that both images have been pulled, PG database and PG admin. Then it created a network automatically. So both containers will stay in the same network, so they will be able to communicate between each other. And we also created the volumes I mentioned, and now both containers are running. Okay, nice. So then we install another VS Code extension named Docker by Microsoft. So go to extensions, search for Docker, and install Docker by Microsoft. And this is pretty cool because now you have access to this panel. You can see the containers that you are running from within VS Code. You can see the images that you just pulled. You can see the networks, volumes, context, a bunch of things, right? Imagine you want to explore, imagine you want to inspect this network. You can do that. You can see the IP addresses and so on. So it's pretty useful in that sense. Now you have everything connected inside VS Code. Yeah, you can also check Docker containers that are running via terminal by running docker ps. Let me create a new terminal, docker ps, and now you see that I have 2 containers running. You see the IDs, the images, and so on. And then you can also check the networks, for example. And we have these 4 networks at the moment. Then we need to set up PGCLI. PGCLI is a Python package useful to interact with PostgreSQL database via terminal. This is a Python package, so we need to install it in the conda environment. But before that, we need to install some PGCLI dependencies. So just run this, run sudo apt-get install lib pq-dev, insert your password, type y, enter, it's installing, it's done. Then pip install PGCLI. Make sure the environment is activated. Pip install PGCLI, enter. It should be installed now. Then connect to PostgreSQL via PGCLI. We are going to access the PostgreSQL database on Docker container. Use the credentials from Docker compose file, meaning that here I defined some environment credentials. The user is root, password is root, the database name is mytestdb, and so on. You can change this, of course. But to use PGCLI, we need to specify the host, the port, the user, and the database name. For that, we use -h, -p, -u, -d, respectively. So if I copy this code, I'm going to use localhost as the host, 5432 as the port, root as the user, and the name of the database is mytestdb. So I want to connect to this. Then the password for root is root, as I defined here. And now, yeah, we are in, basically. We are inside the PG database connected using PGCLI. So now we can run \dt to list the tables. And of course, we don't find any tables because we didn't create them yet. You can also test the SQL command with the following command. So you can run this. So select one as hello world and then semicolon. And you see the output, we are selecting one simply to just test, and the column name is hello world. Nice. Then we can quit PGCLI by running quit, literally. So quit, nice, goodbye. Then we can connect to PostgreSQL database via pgadmin. Both containers have to be connected to the same network in order for pgadmin to connect to PostgreSQL database, and they are at the moment, as I explained before. If we open localhost 8080 in this browser, let's open this, and you see the previously container output, right? This is because of cookies and history in the browser. So I have 2 options. I either press Control-Shift-Delete to delete the cookies and history from the browser. I don't do that. I just do Control-Shift-N to create a new browser private window. And then I just go to localhost 8080. So localhost 8080. And then now I see the pgadmin login page. So now I just use the credentials I defined on the Docker compose file, which is admin@admin.com, and then the password is root, login. Yeah, you can see that here, right? And then I click on servers, it's empty. Then after clicking on servers, I go to object, register, server. Then I just give it a name. Can be test.pg, for example. Then the connection, I need to specify a host name and address. The address should be pg database or host.docker.internal. Why pg database? Well, because my container service named PG database that contains the PostgreSQL database version 13. So now I just use PG database here. Then the username will be root and the password will be root. I save it and the port is 5432 actually. Then I can open test PG databases. Then my test DB, I can click on it and it will connect. Then schemas, public, tables, and I see no tables, of course. Then we can create a sample table via pgadmin. We can create a sample table by opening a query tool and run the following code. Just copy this query, then click here, query tool, paste the code here, create table named cars, and we are specifying 3 columns. Brand and model columns are just string columns, and then we are specifying an integer column named year to store years, and then we execute the script and we should have a table here. Right click, refresh, and we see the new table that we created, cars, with the 3 columns. Then we need to populate the table, right? Because if I right click cars, then view edit data all rows, it will create automatically a query. Select start from public.cars to see what's inside the table, and the output is in the bottom, it's empty, right? So we need to populate the table. So copy this code, then create a new query tool, paste the code here, insert into cars, then the name of the columns, and then the values we want to insert. Execute the script, insert the 3 rows, of course. Then I can right click cars, view edit data, all rows, or I can simply query with select start from, etc. And then I see the populated table here with the data. As an example, we can access the same test table via PG CLI. How? We just go to the terminal, we rerun the same command as previously we did, then the password is root, \dt. Now we see the cars table, and then we can run some query examples. So this one, for example, to select all the data, then you see end here, then you just hit Q in the keyboard to quit this view. Then we can order by year, and now you see the year sorted from top to down, from to bottom, top to bottom actually. Then we can also, I have to press Q first, then I just select start from cars where year greater than 1975, and now I only see BMW M1 with year 1978 because this is the only car with year greater than 1975, right? Yeah, that's it. Now it's time to install Terraform for infrastructure as code to interact with cloud services. So for reference, I created this guide based on the official guide that they have here, so you can check it out if you want. But essentially I have all the steps here. So ensure that your system is up to date and you have installed the GNU-P, software properties common, and curl packages in your system. You will use these packages to verify HashiCorp's GPG signature and install HashiCorp's Debian package repository. Just copy this, okay? Go to the terminal, create a new one, and just run this. Enter your password. And it's done. Then install the HashiCorp's GPG key, copy this, paste it here. Then verify the key's fingerprint, copy this, paste it here, enter. Then you see PUB here, copy this key right here, right click, then go to this link, verify the fingerprint. Go a bit down, find the header named Linux package, checksum verification, and you need to compare the fingerprint from the terminal with this one. So Control F, Control V to paste. It's not a match because there's an additional space in between. So you see, between these two, there's 2 spaces. So delete one and boom, it's a perfect match. If in your system it's indeed a perfect match, after doing this, you can proceed and add the official HashiCorp repository to your system. Copy this, go to terminal, paste it here, run this, then download the package information from HashiCorp, run this, then install Terraform from the new repository by running this. You should have Terraform now. Verify the installation by running simply Terraform. If you see something like this, awesome. You can also run Terraform space version, and you see the version of it. Then run this to install the autocomplete package. Then refresh the terminal. Then if you run Terraform and then tab, it will autocomplete with the possible commands for Terraform, which is very useful. Normally we use Terraform init, Terraform plan, Terraform apply, Terraform destroy, Terraform format, and so on. So then, after verifying this, we can create a directory for testing purposes named test Terraform GCP. So let's copy this. Let's actually go to our project folder and create the directory here. Okay, so it's here, new folder. Then go into it. Okay, so this working directory will store the configuration files that you write to describe the infrastructure you want Terraform to create and manage. When you initialize and apply the configuration here, Terraform uses this directory to store required plugins, modules, pre-written configurations, and information about the real infrastructure it created. So in the working directory, create a file called main.tf. So let me just close everything here. So new terminal. Then I can go to test Terraform GCP and I can code main.tf to create that file. I save the file. You already see the Terraform icon here. Then paste the following Terraform configuration into it, which is just an example to interact with Google Cloud Platform to create a storage bucket and the BigQuery dataset. I've used something similar during the Data Engineering Zoom Camp course by Data Talks Club. So copy this code, paste it here, save the file. Now install the extension on VS Code, HashiCorp Terraform by HashiCorp. So go to the extensions, search for Terraform, go to the one that is signed by HashiCorp, okay, and install it. HashiCorp Terraform by HashiCorp, hashicorp.com. Then close this, and now you see that your file, the main.tf, is highlighted properly with Terraform's color codes, right? This is very useful when specifying these configurations. And yeah, that's it. So now we can initialize the project, which gets provider plugins that lets Terraform interact with GCP. So we run Terraform init from the same folder, okay, where we are storing the main.tf, just to make sure we are in the same folder. Yeah, we are. Then Terraform init. And Terraform has been successfully initialized. So from this point on, we can run Terraform plan, Terraform apply to create the resources in Google Cloud Platform, for example, in this case. And then when we are done, we could run Terraform destroy to delete all the resources there, and that's it. So in this process, two hidden folders should get created, .terraform and .terraform.log.hcl. So if I run LA, I see that folder and that file. So everything looks good. Then, yeah, in a real case scenario, we just run this. I can try to run it, but it won't work because I don't have the credentials from my GCP account here. So in a real scenario, right, I would create a folder inside this directory called keys, and then I would store a mycredentials.json file, and this file would contain the credentials for my service account that I downloaded from GCP, for example, and then Terraform uses those credentials to actually create automatically these resources that I customize here remotely in my GCP account. So it's basically automating infrastructure creation and resources. Then I would Terraform plan to validate what I would be creating. I would run Terraform apply to actually create those, and then I would work, etc. And then once I was done, I would Terraform destroy to delete everything remotely. And man, that's it. In terms of improvements, yeah, of course, improvements are welcome. There's some manual steps in in the steps I showed you that can be automated in the future using shell scripting. We can also use dev containers, Docker, and so on. But yeah, I just wanted to share this with you. I hope that you enjoyed it. It's a bit long, but I think it covers the basics for you starting a course like this or other courses. Me personally, when I started the data engineering Zoom Camp course by Data Talks Club, I think, well, first of all, it's not a course that is very beginner friendly. So I was lucky that I already knew how to do these things, but still I had to learn a lot. But I struggled a little bit in the beginning with the setup. I think everyone struggled a bit with the Docker setup and containerization module 1. But yeah, I just wanted to do this to help other people that are starting to become faster and more efficient. And yeah, I guess I want to help other people to become more aware of coding possibilities, because I came from a mechanical engineering background, and I saw during the initial phase of my career before transitioning to data engineering that a lot of people do a lot of manual work in their daily jobs. I kind of want to use this YouTube channel to find my purpose, whatever that means. It's a bit abstract, but I wanted to help other people breaking loose from these traps or unconscious traps that they can find themselves within works and jobs that they hate. At least if you understand and if you learn about coding, you can focus on the challenge and problem solving process of automating instead of having to do it manually over and over again. So yeah, I hope this video helps someone, and let's keep in touch. Have a nice weekend or week or whatever. Good luck. Peace. Subscribe.